From the scorching heat waves that bake continents to the swirling fury of a superstorm, extreme weather events are a relentless force shaping our planet. They challenge our infrastructure, threaten our lives, and remind us of nature's raw, untamed power. But what exactly drives these colossal phenomena? Is it just the ebb and flow of a dynamic planet, or are we witnessing a more profound, concerning shift? For centuries, humanity has gazed upon the sky with a mix of awe and trepidation. Ancient cultures wove myths around thunder gods and storm spirits. Today, our understanding is built not on myth, but on rigorous science, meteorology, climatology, and a suite of advanced technologies that peer into the very heart of the storm. The Earth's atmosphere is a vast, interconnected engine fueled by solar energy. Differences in temperature and pressure create winds, transport moisture, and unleash the energy that powers every raindrop, every lightning bolt. When these forces become amplified, when the delicate balance is disrupted, extreme weather is born. This documentary dives deep into the intricate science behind these magnificent and terrifying events. We'll explore the atmospheric dynamics that give rise to monstrous hurricanes, the complex mechanics that spawn devastating tornadoes, and the long-term shifts that intensify droughts and floods. We'll examine how scientists predict, track, and attempt to understand these phenomena, hoping to better protect our communities in an increasingly volatile world. Join us as we unravel the mysteries of the science of extreme weather.
Among the most recognizable and feared extreme weather events are tropical cyclones, known as hurricanes in the Atlantic and Pacific, and typhoons in Asia. These colossal storms are essentially giant heat engines. They begin over warm ocean waters, typically above 26.5 degrees Celsius, 80 degrees Fahrenheit, where moist, unstable air rises. As this air cools and condenses, it releases latent heat, further fueling the storm's ascent. The Coriolis effect, caused by Earth's rotation, then imparts the characteristic swirling motion, organizing bands of thunderstorms around a calm central eye. The warmer the water, the more fuel the hurricane has, allowing it to intensify rapidly, sometimes reaching Category 5 on the Saffir-Simpson scale, with winds exceeding 157 miles per hour. In stark contrast but equally destructive are tornadoes. These violent, rotating columns of air descend from powerful thunderstorms, primarily supercells. They form when there's a unique combination of warm, moist air near the ground and cool, dry air above, creating atmospheric instability. Crucially, a change in wind direction and speed with height, known as wind shear, causes the air to rotate horizontally. This horizontal rotation can then be tilted vertically by the storm's updraft, forming a mesocyclone within the thunderstorm, from which a tornado may eventually descend. Scientists use advanced Doppler radar to detect these rotating columns, issuing warnings that are often measured in minutes, a stark reminder of the rapid and localized nature of these destructive forces, categorized by the enhanced Fujita scale based on damage.
Beyond the spectacular fury of hurricanes and tornadoes, other extreme weather events exert a relentless, often slower burning, but equally devastating toll. Heat waves, for instance, are becoming more frequent, longer, and more intense across the globe. These prolonged periods of abnormally high temperatures are often caused by persistent high-pressure systems, known as heat domes, which trap hot air near the surface. Such heat can buckle infrastructure, spark wildfires, and pose severe health risks, particularly in urban areas. The science is clear. Human-caused climate change is making these events more likely and more severe as the planet's average temperature continues to rise. Droughts and floods represent two sides of the same hydrological extreme. Droughts, characterized by prolonged periods of insufficient precipitation, are intensified by higher temperatures, which increase evaporation and dry out soils. They devastate agriculture, deplete water resources, and exacerbate wildfires. Conversely, floods, whether flash floods or riverine floods, are driven by excessive rainfall. Warming temperatures mean the atmosphere can hold more moisture, about 7% more for every degree Celsius of warming. This increased atmospheric moisture can lead to heavier downpours when conditions are right, overwhelming drainage systems and causing widespread inundation.
We're also observing the phenomenon of atmospheric rivers, narrow corridors of concentrated moisture in the atmosphere, which can deliver tremendous amounts of rain and snow, often leading to extreme flooding events, particularly along coastlines and mountain ranges.
The challenge of extreme weather is escalating. As our climate continues to warm, fueled primarily by greenhouse gas emissions, scientists predict an increase in the frequency and intensity of many of these events. Climate models, powered by supercomputers crunching vast datasets, paint a concerning picture of a future with more extreme heat, heavier precipitation events, and potentially more powerful tropical storms. Understanding these projections is not about fear-mongering, but about informed preparedness and action. The science of extreme weather is therefore not just about explaining past events, it's about predicting the future and guiding our response. This involves sophisticated monitoring networks, from ground-based sensors to orbiting satellites, constantly feeding data into predictive models. It also involves the crucial work of communicating risks effectively to the public. Beyond prediction, adaptation strategies are vital, building more resilient infrastructure, developing early warning systems, managing water resources more intelligently, and improving land use planning. Mitigation, however, remains the ultimate long-term solution. Reducing our carbon footprint, transitioning to renewable energy, and embracing sustainable practices are essential to slow the pace of climate change and, by extension, temper the severity of future extreme weather. The science is a call to action. It empowers us with the knowledge to confront these formidable forces. While we cannot stop nature's power, we can learn to live with it more safely, protect our planet, and build a more resilient future. The journey to understanding extreme weather is ongoing, a testament to human curiosity and our collective will to survive and thrive amidst nature's fury.
Subscribe to the channel and hit the bell icon for more amazing content.